When selecting an outdoor emergency 2-bulb light, consider several high-quality brands known for their durability and reliability. Cooper Lighting offers a wide range of models designed for harsh outdoor environments. RAB Lighting provides a variety of LED and HID emergency lights with advanced moisture sealing and weatherproof construction. Lithonia Lighting is a trusted brand for commercial and industrial lighting, including outdoor emergency lights with robust enclosures and wet location ratings. Hubbell Lighting provides high-performance emergency lights with highly visible LED illumination and moisture-resistant construction. Latron Electronics, renowned for its innovative lighting control solutions, offers outdoor emergency lights with advanced dimming and sensor options. When evaluating these lights, consider key features. Firstly, a wet location rating ensures the light is protected from rain, snow, and other moisture. Secondly, durable construction is important. Choose lights with corrosion-resistant materials like aluminum or stainless steel. Thirdly, long battery life is essential. Look for lights with batteries that last at least 90 minutes in emergency mode. Fourthly, LED illumination provides brighter, more energy-efficient lighting than traditional bulbs. Fifthly, ease of installation is important. Select lights with user-friendly mounting hardware and clear instructions. It is also important to check the IP, ingress protection, rating on the light to ensure it meets the desired level of moisture protection. Consider a light with a dusk-to-dawn sensor to automatically activate the light at night. Place the light in a visible and easily accessible location. Test the light regularly to ensure it is in proper working order. The ingress protection (IP) rating is a 2-digit number that defines the levels of protection provided by electrical enclosures against intrusion from foreign bodies, dust, accidental contact, and water. The first digit indicates the level of protection that the enclosure provides against access to hazardous parts, for example, electrical conductors, moving parts, and the ingress of solid foreign objects. The second digit indicates the level of protection provided by the enclosure against harmful ingress of water. For outdoor emergency lights, a rating of I65 or higher is recommended. I65 means the enclosure is dust-tight and protected against water jets from any direction. I66 means the enclosure is dust-tight and protected against powerful water jets. I67 means the enclosure is dust-tight and protected against the effects of temporary immersion in water. I68 means the enclosure is dust-tight and protected against the effects of continuous immersion in water. These ratings are crucial because outdoor emergency lights are constantly exposed to the elements, and a high IP rating ensures that the internal components are protected from damage and corrosion. Regarding battery life, emergency lights are required to provide illumination for a minimum of 90 minutes during a power outage. This is a standard requirement in many built-in codes and regulations. The battery should be capable of providing sufficient power to the light source for the entire duration of the emergency. Factors that affect battery life include the type of battery, the ambient temperature, and the age of the battery. Regular testing is essential to ensure that the battery is in good condition and can provide the required illumination time. LED illumination offers several advantages over traditional incandescent or fluorescent bulbs in emergency lighting applications. LED are more energy efficient, meaning they consume less power and produce more light per watt. This translates to longer battery life and lower operating costs. LED are also more durable and have a longer lifespan than traditional bulbs, reducing the need for frequent replacements. Additionally, LED provide instant illumination, whereas some traditional bulbs may take a few seconds to reach full brightness. LED are also available in a variety of colors and brightness levels, allowing for greater flexibility in lighting design. When installing an outdoor emergency light, it is important to choose a location that is visible and easily accessible. The light should be mounted at a height that provides adequate illumination, but is not too high to make maintenance difficult. The light should also be positioned away from obstructions that could block the light output. The mounting surface should be strong enough to support the weight of the light and should be resistant to corrosion. It is also important to follow the manufacturer's instructions for installation to ensure that the light is properly wired and grounded. Regular testing is essential to ensure that the emergency light is in proper working order. The testing should be performed according to the manufacturer's instructions and should include a visual inspection of the light, a battery test, and a functional test. The battery test should verify that the battery can provide the required illumination time. The functional test should verify that the light turns on automatically when power is lost and that the light output is sufficient. Any problems that are identified during testing should be corrected immediately. The frequency of testing should be determined by the manufacturer's recommendations and any applicable codes or regulations. For example, some jurisdictions require monthly or annual testing of emergency lighting systems. Proper maintenance is also essential to ensure that the emergency light remains in good working order. The light should be cleaned regularly to remove dirt, dust, and debris. The battery should be replaced according to the manufacturer's recommendations. Any damaged or worn part should be replaced immediately. A record of all testing and maintenance should be kept to document the condition of the light and any repairs that have been performed. Codes and regulations governing emergency lighting vary depending on the jurisdiction and the type of building. It is important to consult the applicable codes and regulations to ensure that the emergency lighting system is compliant. Some common codes and regulations include the National Electrical Code, NEC, the Life Safety Code, and the International Building Code, IBC. These codes and regulations specify requirements for the design, installation, testing, and maintenance of emergency lighting systems. They also specify requirements for the type of lighting fixtures, the battery backup, and the illumination levels. Compliance with these codes and regulations is essential to ensure the safety of building occupants during a power outage or other emergency. Furthermore, understanding electrical codes is crucial for anyone involved in the installation or maintenance of electrical systems. The National Electrical Code, NEC, is a widely adopted standard in the United States that provides guidelines for safe electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect changes in technology and best practices. Compliance with the NEC is essential to ensure the safety of people and property. The NEC contains numerous articles and sections that are relevant to emergency lighting systems. For example, Article 700 covers emergency systems, Article 701 covers legally required standby systems, and Article 702 covers optional standby systems. These articles specify requirements for the source of power, the transfer equipment, the wiring methods, and the overcurrent protection for emergency lighting systems. The NEC also contains requirements for the illumination levels and the duration of illumination for emergency lighting systems. These requirements are designed to ensure that building occupants can safely evacuate the building during a power outage or other emergency. Furthermore, overcurrent protection is a critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. Excessive current flow can cause overheating, damage to equipment, and even fires. Overcurrent protection devices are designed to interrupt the flow of current when it exceeds a safe level. The NEC specifies the requirements for overcurrent protection devices, including the type of device, the ampacity rating, and the location. It is important to select the correct overcurrent protection device for each circuit to ensure that it is properly protected. Grounding is another essential aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source. This helps to prevent electrical shock and reduce the risk of fire. The NEC specifies the requirements for grounding systems, including the type of grounding electrode, the size of the grounding conductor, and the location of the grounding connections. It is important to properly ground all electrical equipment to ensure the safety of people and property. Additionally, consider the use of automatic transfer switches. An automatic transfer switch, ATS, is a device that automatically transfers power from a normal source to an emergency source when the normal source fails. This ensures that critical loads, such as emergency lighting, continue to be powered during a power outage. ATS are commonly used in hospitals, data centers, and other facilities where continuous power is essential. The ATS monitors the voltage and frequency of the normal power source. If the normal power source fails, the ATS automatically switches to the emergency power source, such as a generator or a battery backup system. When the normal power source is restored, the ATS automatically switches back to the normal power source. ATS are available in a variety of sizes and configurations to meet the needs of different applications. Proper installation and maintenance of ATS are essential to ensure their reliable operation. Remember the importance of surge protection. Surge protection devices, SPDs, are designed to protect electrical equipment from voltage surges or spikes. Voltage surges can be caused by lightning strikes, power outages, or other events. SPD divert the surge current to ground, preventing it from damaging sensitive electronic equipment. SPD are commonly used to protect computers, televisions, and other electronic devices. The NEC specifies the requirements for SPD, including the type of device, the voltage rating, and the location. It is important to install SPD at the service entrance and at any sensitive equipment to provide comprehensive surge protection. Also, don't forget about arc fault circuit interrupters. Arc fault circuit interrupters of size are designed to protect against fires caused by arcing faults. Arcing faults occur when electricity jumps from one conductor to another, creating a high temperature arc. ASIs detect arcing faults and interrupt the flow of current, preventing a fire from starting. ASIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. The NEC specifies the requirements for ASIs, including the type of device and the location. It is important to install ASIs in all required areas to protect against electrical fires. Furthermore, be aware of ground fault circuit interrupters. Ground fault circuit interrupters, GFCIs, are designed to protect against electrical shock. GFCIs detect ground faults, which occur when electricity leaks to ground. GFCIs interrupt the flow of current when a ground fault is detected, preventing an electrical shock. GFCIs are required in many areas of the home, including bathrooms, kitchens, and outdoor areas. The NEC specifies the requirements for GFCIs, including the type of device and the location. It is important to install GFCIs in all required areas to protect against electrical shock. Consider energy-efficient lighting. Energy-efficient lighting can save money on electricity bills and reduce the environmental impact of lighting. Energy-efficient lighting options include LED lamps, compact fluorescent lamps, CFLs, and high-intensity discharge (HID) lamps. LED lamps are the most energy-efficient option and have a long lifespan. CFL are also energy-efficient but contain a small amount of mercury. HID lamps are used in high-bay applications and are very energy-efficient. It is important to choose the right type of lamp for each application to maximize energy savings and minimize environmental impact. Also, understand lighting controls. Lighting controls can be used to reduce energy consumption and improve the functionality of lighting systems. Lighting controls include occupancy sensors, daylight sensors, and dimming systems. Occupancy sensors turn lights off when a space is unoccupied. Daylight sensors dim lights when natural light is available. Dimming systems allow users to adjust the light level to suit their needs. It is important to choose the right type of lighting control for each application to maximize energy savings and improve the functionality of the lighting system. It's important to understand wiring methods. Wiring methods refer to the techniques and materials used to install electrical wiring. Common wiring methods include conduit, cable, and wireways. Conduit is a rigid metal or plastic tube that protects electrical conductors. Cable is a factory-assembled group of conductors enclosed in a sheath. Wireways are metal troughs or channels that are used to support and protect electrical conductors. The NEC specifies the requirements for wiring methods, including the type of wiring method, the size of the conductors, and the support requirements. It is important to choose the right wiring method for each application to ensure the safety and reliability of the electrical system. Consider the use of electrical boxes. Electrical boxes are enclosures that protect electrical connections and provide a mounting point for electrical devices. Electrical boxes are available in a variety of sizes and shapes to accommodate different types of devices and wiring methods. The NEC specifies the requirements for electrical boxes, including the type of box, the size of the box, and the mounting requirements. It is important to choose the right type of electrical box for each application to ensure the safety and reliability of the electrical system. Also, be aware of conductor ampacity. Conductor ampacity is the maximum current that a conductor can carry without exceeding its temperature rating. The NEC specifies the ampacity of different types of conductors based on their size, insulation type, and ambient temperature. It is important to choose conductors with sufficient ampacity to carry the load current without overheating. Overheating of conductors can cause damage to the insulation, which can lead to electrical shorts and fires. Also, the NEC contains tables that specify the allowable ampacity of conductors in different conditions. It is important to consult these tables when selecting conductors for electrical installations. Furthermore, consider voltage drop. Voltage drop is a decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause electrical equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. It is important to calculate the voltage drop for each circuit to ensure that it is within the allowable limits. Voltage drop can be reduced by increasing the size of the conductors or by shortening the length of the circuit. In addition, be aware of short circuit current rating. The short circuit current rating, SCCR, is the maximum short circuit current that an electrical component or system can withstand without being damaged. It is important to ensure that all electrical components and systems have a SCCR that is greater than or equal to the available short circuit current at the point of installation. Failure to do so can result in equipment failure, electrical fires, and personal injury. The available short circuit current can be calculated using various methods, including the point-to-point method and the infinite bus method. It is important to consult with a qualified electrical engineer to determine the available short circuit current for each installation. Furthermore, consider the use of transformers. Transformers are used to step up or step down voltage levels in electrical systems. Transformers are commonly used to supply power to low voltage equipment from a higher voltage source. Transformers are also used to isolate electrical circuits from each other. The NEC specifies the requirements for transformers, including the type of transformer, the voltage rating, and the overcurrent protection requirements. It is important to choose the right type of transformer for each application to ensure the safety and reliability of the electrical system. Also, be sure to use proper lockout-tagout procedures. Lockout-tagout (LOTO) procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. LOTO procedures involve isolating the equipment from all sources of energy and placing a lock and tag on the disconnecting means. The lock and tag indicates that the equipment is not to be energized until the lock and tag are removed by the authorized person. LOTO procedures are essential to prevent electrical shock and other injuries during maintenance or repair. OSHA, the Occupational Safety and Health Administration, has specific requirements for LOTO procedures. It is important to follow these requirements to ensure the safety of workers. Remember the importance of arc flash hazard analysis. Arc flash hazard analysis is a study that is performed to determine the potential arc flash hazards in an electrical system. Arc flash is a dangerous phenomenon that can occur when electricity arcs through the air. Arc flash can cause severe burns, electrical shock, and even death. An arc flash hazard analysis involves calculating the incident energy, the arc flash boundary, and the required personal protective equipment (PPE). The results of the arc flash hazard analysis are used to develop safety procedures and to select the appropriate PPE for workers who are working on or near energized electrical equipment. AE 1584 is a standard that provides guidance on performing arc flash hazard analysis. Also, be aware of personal protective equipment. Personal protective equipment, PPE, is used to protect workers from electrical hazards. PPE includes items such as gloves, sleeves, face shields, and flame-resistant clothing. The type of PPE that is required depends on the potential hazards that are present. It is important to select the appropriate PPE for each task and to ensure that workers are properly trained in its use. OSHA has specific requirements for PPE for electrical workers. It is important to follow these requirements to ensure the safety of workers. When selecting PPE, it is important to consider the arc rating of the clothing. The arc rating is a measure of the protection provided by the clothing against arc flash hazards. The arc rating is expressed in calories per square centimeter, cal per cm squared. The higher the arc rating, the greater the protection provided by the clothing. It is important to select clothing with an arc rating that is appropriate for the potential arc flash hazards in the workplace. Finally, remember the importance of electrical safety training. Electrical safety training is essential for all workers who work on or near electrical equipment. Electrical safety training should cover topics such as electrical hazards, safe work practices, low-tow procedures, arc flash hazard analysis, and the use of PPE. Electrical safety training should be provided by a qualified instructor and should be updated regularly. OSHA has specific requirements for electrical safety training. It is important to follow these requirements to ensure the safety of workers. In addition to formal training, it is important to provide workers with on-the-job training and supervision. On-the-job training should be provided by experienced workers who are familiar with the potential hazards and safe work practices. Supervision should be provided to ensure that workers are following safe work practices and are using the appropriate PPE.